Welcome back. And in this lecture, we are going to learn about convolutional neural networks, or convnets, or CNNs for short. A convolutional neural network makes the explicit assumption that the inputs are images. This allows us to encode certain properties into the architecture. These then make the forward function more efficient to implement and vastly reduce the amount of parameters in the network. The layers of a CNN have neurons arranged in three dimensions: width, height, and depth. Now, notice that the word depth here refers to the third dimension of the activation volume, not the depth of a full neural network, which is usually referred to as the total number of layers in the network. Also, we use three main types of layers to build a convolutional neural network. The first layer is the convolutional layer. The second layer is the pooling layer. And the third layer is the fully connected layer. The key idea here is that we are doing a convolution over neighboring edges of the image. So for a given edge, the edge-to-edge filter convolves over neighboring edges of that given edge. As you see in the yellow cross or filter sliding over the input on the left to produce the output responses on the right. While in the edge-to-edge filter, we do a convolution or a weighted sum over neighboring edges with respect to an edge. In the edge-to-node filter, we do a convolution over the neighboring edges with respect to the node. We do a convolution or a weighted sum over its neighboring edges, where neighboring edges are defined as all edges directly connected to the node. The node to graph filter is equal to a fully connected layer when applied after an edge to node filter. The edge to node filter summarizes the neighboring edges with respect to a single node, and the output represents the weighted sum of the edges adjacent to a specific node. Applying a fully connected filter to the responses of edge-to-node filter gives us a single response that summarizes all the nodes into a single graph response. So let's see how this works on a face recognition neural network.
Let's start off with face detection. Now, face detection is something we already have in our SDK, but we're offering in the Vision Framework new this year a face detection that's based on deep learning. And you may already know that deep learning has made groundbreaking changes in the accuracy and what we can do with vision technologies, and face detection is no exception. We're going to have higher precision, which means fewer false positives, but we are also going to have dramatically higher recall, which means we'll miss less faces. So let's look at some of the examples of faces that we will now be able to detect with the Vision Framework. For one thing, we'll be able to detect smaller faces. We'll also be doing a better job of detecting strong profiles. We'll also do a better job of detecting more partially occluded faces, and that includes things like hats and glasses.
So if you have not downloaded the Swift Vision API Project 2 starter project, go ahead and do so now. And we're going to get started with our face detection application. So the first thing we want to do is to programmatically call in a image to our application, and we'll do that under our view did load. And I've already imported 2 pictures. In our assets folder, okay, called EG detect and EG detect 2. You can use your own pictures. Just make sure that there are faces available to be detected with the application. But these are the 2 in your starter project. Now we will pull a request with the vision detect face rectangles request function. Then we need the results. And we just need to finish calling our handlers for the face detection. Let's clean this up really good. To clean up your code, you just select Command All and then Control I. That cleans up your syntax. So we'll do the handlers now. Guard let. So with that, let's go ahead and run our app. And let's see, we're detecting the faces, 3 of the 4 faces in the front row. The second row, we're detecting 1 face and 1 face in the third row. It's not, however, it's not detecting way back here or these 2 faces. So let's switch images here. Get it out the way. 2 there. We'll rerun the app. And it seems to be detecting all of the faces here in this female hockey league. So that is the Vision API face detection. And that can be integrated with models as well. We didn't even have to use a model for the face detection. If you add a model to it, it can be even more powerful. And we will be going over models in our next project. So we'll see you there.